Sweetwater Wetlands Park has been around for approximately 3 years and is a product of the Paynes Prairie Sheetflow Restoration Project. The park serves a dual purpose as both a natural water filtration system and a habitat for Florida wildlife. It processes 5 million gallons of water per day at a flow rate of approximately 10 cubic feet per second. The main inflow for this park comes from the Main Street Water Treatment Plant in Gainesville. The park was designed to help eliminate excess pollutants from urban areas. Every day, debris such as toys, TVs, and tires flow into the Sweetwater Wetlands Park and are successfully filtered out of the water supply. Today, we'll discuss in detail the history of the park, the elements of the Paynes Prairie Sheetflow Restoration Project, and the process by which a natural wetlands cleans water and returns it to the water sink.
Now I'm going to talk a little bit about the history of Sweetwater Wetlands Park. Originally, the Paynes Prairie was once used as the land for cattle. The ranchers built the Sweetwater Branch Canal in order to create dry land for the cattle to graze. This disrupted the natural sheet flow onto the prairie and dehydrated the wetlands and killed a lot of the natural plants. The canal led directly into the Alachua Sink, which feeds directly to the Floridian aquifer. This caused a major problem because the canal was carrying untreated wastewater and stormwater from the city of Gainesville. This water was contaminated by the harmful nutrients such as nitrogen and phosphorus. These nutrients were allowed to get into the Floridian aquifer and contaminate a large portion of Florida's drinking water. This water also contained trash, debris, and pollution from septic tank sources. Because of this, the Florida Department of Environmental Protection rated Alachua Sink as an impaired waterway, which did not meet drinking water standards. Because of this, the Paynes Prairie Sheetflow Restoration Project was conceived. This project had hopes of reversing these negative impacts of urbanization, so the project came up with the idea of Sweetwater Wetlands Park. This park is up and running today because of the donations and assistance from the City of Gainesville, GRU, the Department of Environmental Protection, Florida Department of Transportation, St. Johns River Water Management District, and Alachua County.
Sweetwater Wetlands takes up approximately 125 acres due to the high potential for large rainfall events. Sweetwater Branch flows through Gainesville, collecting stormwater, runoff, and treated wastewater, bringing it directly into the Sweetwater Branch Creek. From here, the water moves to the treatment system, first passing through the sediment basin, collecting any trash and removing large sediments at a low speed. Next, the water moves through what's called as a forebay, which further removes fine sediments at a low speed. From here, the water is divided up into 3 separate pools, known as the enhancement wetlands. The water moves the entire length of the pool in order to remove any unwanted bacteria and other contaminants. Water is transferred from the forebay to the enhancement wetlands through individual water pumps, which periodically transfer the necessary amount of water based off the pool's water level. The enhancement wetlands' primary objective is to remove harmful nutrients such as nitrogen and phosphorus. After the water is successfully passed through the enhancement wetlands, the water is distributed to a canal which further spreads the water to Paynes Prairie. The park also has features specific to areas near each pool and canal. For example, bigger trees such as the bald cypress and black gum tree are located on an area called the upland hammock, which is essentially an area of raised ground separating the pools and the enhanced wetland. These trees are essential to the park as they give the wildlife a habitat to live in. Dead trees also provide shelter for wildlife around the park. Another area in the park is called the emergent marsh, which is about 8 to 12 inches in depth. This area is a flat, shallow section of water that is home to many animals such as the Florida soft-shelled turtle, many fish, and the American alligator. The emergent marsh is directly connected to the deep pool, which serves as the habitat for many larger alligators and fish.
Enhancement wetlands are very cost-effective at cleaning water and improving water quality because they use free sunlight and water to power treatment. Solar radiation and ample water combine to create high plant productivity. There are also no chemical inputs or fossil fuels needed. The plants in the wetlands are able to survive by taking up oxygen in very unique ways as compared to plants on land. Many of the plants underwater have air-filled cavities which facilitate oxygen uptake throughout the plant. The natural wind also helps to cool the plants by pulling air and water up through them. The floating plants have air spaces throughout their tissues which help to keep them afloat. The ability to float is critical to these plants in getting adequate amounts of sunlight. Nutrients such as phosphorus and nitrogen can cause harm to the environment if they are present in large amounts. When there is an abundance of phosphorus in water, it can lead to the speed up of eutrophication. This rapid increase in algae can cause microorganisms to quickly deplete oxygen levels in the surrounding area. With loss of oxygen can come large fish die-off. Excess nitrogen levels in water have been shown to lead to a restriction in oxygen transport in the bloodstream. The pollutant nitrate nitrogen comes from wastewater treatment operations, fertilizers, and septic tanks. In order for the water to be safe, these two nutrients must only be present in low quantities. The wetlands are very effective for nitrogen and phosphorus removal. Contaminated water will be filtered by plants, microorganisms, and soil within each of the 3 cells. The plants support bacteria necessary for denitrification, which is the conversion of nitrate nitrogen to nitrogen gas. The nitrogen gas is then released harmlessly into the atmosphere.